Here's a scenario for you. You just spent this wonderful Sunday at the local aquarium, and you saw a bunch of exotic fish, and you got to see their behavior. And your daughter gets so excited, on the way home she tells you about the aquarium she has in her school. Now later that night, there's a segment on divers getting up close and personal with sharks.
This shark is munching down on the bait bag right now.
And your son gets so excited he goes online and follows the conversation live.
Check this out.
The fact is, an awful lot of science learning goes on outside of the classroom. It goes on in libraries and museums and nature centers and after-school groups, and sometimes in conversations around the dinner table.
We're really expanding our idea about where people can learn science and how they can kind of put their knowledge of science together across their lives, putting together what they learn in school with what they learn outside of school.
We've come to understand that proficiency in one aspect of science is very closely related to proficiency in another, like strands of a rope. The strands of scientific proficiency are intertwined. The strands support each other, so that progress along one strand promotes progress along another.
The 6 strands allow me to find a roadmap on the experiences I want to provide or experience I want to have for myself.
So it's this nice lens for broadening how we think about what it means to learn science and the kinds of experiences we provide to people to learn science.
Interest, motivation, excitement. That part of the strand is probably the easy one to recognize. If you get an amateur astronomer out there in a starry night to not only observe through the telescope, but then share that with people at a star party, excitedly speaking about how wonderful it is to see the moons of Jupiter through that telescope, and say, look, this is not just an image of Jupiter, this is Jupiter.
Strand 2, Understanding Scientific Knowledge, really emphasizes a deeper understanding the relationships between ideas, and being able to provide more sophisticated explanations. So it's not just the factoid answer, it's really explanations about that answer. So if you learn something about a dinosaur and you use something about evolution, you might come to understand how it is that the dinosaur could be related to birds.
While this strand includes what is usually categorized as content, it focuses on concepts and the links between them rather than on discrete facts. And it also includes the ability to use that knowledge in a person's own life.
The point of being able to reason from evidence is the notion that science is changing all the time. The nature of science lies in the fact that it looks at evidence and it corrects itself, it builds on things that are solid, new ideas are being created. And what people should do when they're proficient in science and competent in science is understand that reasoning, making logical arguments based on evidence, is helpful.
And many informal environments give people the opportunity to test, to explore, to examine, to manipulate, to get a feel for the physical and natural world. And it's that sort of experience that allows the visitor to actually engage in scientific reasoning.
We can learn new things about the world, and it might mean we need to update our explanations of the world. Often historical examples can be a really good way of helping people to understand how scientific knowledge emerges over time and is reshaped as new evidence comes in.
There are many, many opportunities, both informal as well as mostly in informal settings, that allow people to take part and thereby become much more knowledgeable about the way in which having scientific tools and language helps communicate and do work.
In terms of language, we don't just mean the wacky terms that scientists come up with. It's also the way you frame an argument. The strength of your argument rests on the strength of your evidence and how well your explanation fits the data.
By engaging in scientific activities, people actually gain greater facility with the language of science. Terms like hypothesis and control group and experiment and data analysis start to feel more familiar, and non-scientists can gain entry into the culture of the scientific community.
Again, it's this idea that science is for everyone, that we don't want to exclude anybody, and that to give people an opportunity to be part of science in as much as they want and as little as they want, based on their own preference, rather than based on prejudice or fear or a sense of lack of empowerment. The question between formal learning and informal learning is, to what degree does formal learning provide you with a foundation that allows you to continue an individual lifelong learning path that is then lifelong, as they say, life wide and life deep.
You don't, in every science learning experience, at every moment, have to highlight all 6 strands. They can sort of come in and out and trade off across your experiences. It's looking over the whole arc of time.
Informal environments have often been recognized as critically important to developing positive, science-specific interests, attitudes, and identities. Designers and educators can realize those goals for people of all ages by portraying science as a social, lived experience relevant to people's lives. The fact is, learning science outside the school is fun, it's exciting, it's engaging, and we now know that all of those qualities are essential to effective science learning.